settings, audio. I don't know, F. Okay, so in the stream? No, we're good. We're good. We're good. Okay. And then, hello. Hello. What we're going to do is we're going to read the Abacus if you are interested. Hello. Hello. Oh, there we go. 1, 1, and 2. Hello. Hello. Minor. How are you doing today? Today we're going to be talking about the Abacus. This is what the Abacus is. It is a counting tool. Do you know what an Abacus is? Have you ever seen an Abacus? So what we're going to do is we're going to read the Abacus. This is 1. This is 1. That's 1. How do I know this is 1? This is 1 because this bead is touching the horizontal bar. This bead is touching the horizontal bar. This is the horizontal bar that counts all our Abacus, all our beads. This is the one that counts all our beads. So then if I did this, this would be 2. Because this is 2, right? It's easy. And that's 2. So that's what it is. It's 2. So when the 2 bottom beads are touching the beam, these beads are being counted, are counted. The Abacus displays 2, 1, 2. And then this is 3. So here it's the same thing. 3 bottom beads. These are the bottom beads. This is the horizontal bar. This is the horizontal bar. They call it the reckoning bar or they kind of call it a beam. But I call it the horizontal bar. We could call it a beam. So this is 1, 2, 3, and this is 4. 1, 2, 3, 4. Notice that I have four bottom beads, 4 bottom beads, 4 bottom beads touching this horizontal bar. Because it's touching the horizontal bar, I have 1, 2, 3, 4. This is the horizontal bar. So now, if you look, all of these columns is 0, but this one is 4. So when I look, I have 5. This is 5. Because this is 5, 1, 5, we have our numbers. So this is what 5 looks like. Hello, Gabby. And then this is 5. So if we look, this is 5. Now what's 6? Well, if we notice what 6 is, hello, Falcor and Baba and Donku. So if we want to do 6, we have 1. We notice we've done 1 before, right? We've done 1, but when we add the 5, now we have 6. We have 5, 6. Let me know if you guys have any questions because I'm feeling I'm by myself. And I really enjoy when people come in and say, hello, good morning. Hello, welcome back. I'm so happy you're here. Nobody else is here. Well, nobody else has commented, so I don't know who else is here. But thank you so much for joining, Dean. Okay, so we have 5 and 6. And then if we remember, this is 2. Because this is 2, if everybody's if everybody's here, this is what is this what they do to the quick math with their hands? Yes. Yes, Alex, that is what they do. They're more dramatic, but this is exactly what they do. I'm always interested in about how these things work. Thank you so much for commenting, Danku. Yes. So what we're doing is we're learning how to read the abacus, and after we're going to learn how to read the abacus, we'll go into adding, subtraction, multiplication, division. It depends on how far we can get with division. But the first thing we're going to do is understand. And so then, Alex, if you notice, when I start moving my fingers like this is what the kids will do because they have it in their mind that they can see the abacus. So notice I have 2 here, and then when I add the 5, it's here. It's quiet but nice too. Dean, I was going to go straight into like this. Yeah, they just memorized the abacus. Yes. Thank you, Dean. 5, 6, 7. So what we're doing is we're learning how to read the abacus. And because we're learning how to read the abacus, we will figure out how to add and subtract. So we have 5, 6, 7. So notice when I have 3, 1, 2, 3, all these beads are touching this horizontal bar. This is the 3. So because this is 3 and I add the 5, now we have 8. And again, if I have 4, 1, 2, 3, 4. Now, usually when I count, I'm not going to be 1, 2, 3, 4. I'm going to be 4. This is 4. 4. So when I add 4 and then I add the 5, the top bead, the 5, then this is now considered 9. Anybody else has any questions? So one of the question might be is why am I starting in the middle? It's kind of in the middle. Why am I starting here? Because I have this thing called a dot indicator. This is my ones label. Now, if you notice, my ones label can be either or. It can be either here or it can be here. Wow, this is really good lighting. I'm really impressed. That's what happens when I do this in the morning. I have really good lighting. Okay, sorry. So when you look at this is my ones, this is my tens, this is my hundreds, this is my thousands. So then what we're doing is we are focusing on the place values. So when you look, just as we write, we have our ones, our tens, our hundreds, our thousands, our 10,000. When we have this, we have 10. When we look, this is 10. This is 0 and 10. So they start doing it, and then they start doing it with their hands. Yes, exactly, Alex. So what happens is they first know how to move the beads. Well, first they know how to read the abacus, then they know how to move the beads. After they know how to move the beads, then they go into multiplication, division, subtraction, multiplication, and division. Yes. Addition. Did I say addition or did I say multiplication twice? But anyways, yes. So that's what they do, and that would be the order. The order is. Oh, you know what? Maybe I should write it out. So the order is what? The first thing we need to do is we need to understand how to read the abacus, right? Once we learn how to read the abacus, right? After we learn, then we'll learn how to move the beads. After we learn how to move the beads, we will go into addition, oh, subtraction, multiplication, and division. That's the first thing we got to do. The first thing we're here right now. We're here because we need to understand how to read the beats. Make sense? So the first thing, and then so if we notice, this is. Maybe I should do that. There you go. All right. Yeah, not a problem. Thank you for the questions, Alex. Thank you so much for the questions. I appreciate that. Okay, so what are we doing is we are reading the columns. We have our ones, our tens, our hundreds, our thousands, our 10,000s. So if I did this, right, what number do you think this is? What number do you think this? Maybe I should put it on the side because I don't need to. What number do we think this is? So if I did that, yeah, 101. Oh, no, not really. Because I have five, right? The top bead will always be five. Because the top bead is five, this is five. This is two, one, two, and then this is five, six, seven, eight. So I have 825. That's what that is. So let's do a little review. When we talk about it, this is one, two, three, four, and then five. The top bead will always be five. When we have when we have one and then we add the five, now we have six. So then we have two, right? So your number, I need the lesson. I wish my little nephew was here learning. You know what? I'm always here. So Alex, your number was 101. It is 101. That's what your number was. So when I had it, it was actually 825. Do you see that there's a difference? So thank you for the follow, Donku. Anybody have any questions? So then let's continue on learning how to read the abacus. We'll do one, two. How old is your nephew, Alex? One, two, three, four, and then five. After five, we have six, seven, eight, nine. So we read from left to right? Yeah, we do. You know why? Because we read from left to right because we have 1,563, right? We don't say 360, 500, 1,000. Oh, he's six. That's perfect. If you really wanted to, Alex, I do have a book. I have books. I got books. I've got abacus books. I've got abacus books if you want them to learn how to read the abacus. And so this one was more for the younger kids. But I do have books and I do have stuff. I have stuff. If you want, I have this. There is this. What is this? I have this reference sheet. If you want, this is my link in my bio. There's a link in my bio if you want a reference sheet on how to read the abacus. I don't know how I ended up here, but I'm all for it. Yeah, thank you, Murph. So Murph has a number at the end. His number is 555566. That's what that number is. Thank you. You're welcome. Thank you. Okay, so yes, B. Does that make sense, B? Thank you, Bell. Yes, the top B will always be five. And so Bell, not Bell, B. B, did that make sense? When we're reading, right, we don't read from right to left. We read from left to right, just like as we read. So, before I forget, if you want some books, I've got my books. I have it here. If you're looking for a 13 column abacus, right now I'm trying to figure this out. And then this is 13 columns. And then this is my website, link in bio. If you're looking for other worksheets, you can go to Teachers Pay Teachers or my link in my bio. Yep. Thank you so much. Thank you. Yes. Okay. Great. Yeah. I'm not here to. I just think it's interesting, right? Because it's a new thing, and people are like, I don't understand what I'm doing here. And so what we're doing is we're going to learn how to read the abacus. After we learn how to read the abacus, then we'll go into adding, subtraction, multiplication, and division. So maybe what I should do. Oh, this is what my big brains notes is. So we're looking at it, right? And when we look, we're going to do a review again. So the review is if I have all my, this is 0, because this is 0, none of the beads are touching. And this is 1, this is 2, this is 3, 4. Now, if you notice, I have 4 beads touching the horizontal bar. Then none of these columns are counted. Why? Because none of the beads are being touched. None of the beads are touching the horizontal bar. So this one they're all holding hands. So because they're all holding hands, then they're all being counted. So then what's after 4? After 4 is 5. The top bead will always be 5, no matter what. No matter what. So if I did this, this is 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. These are all 5s. If I did this is all 4, 4, 4, 4, 4, 4, 4, 4, 4. What happens after this? Well, if you notice, I have a decimal that sits between the ones and the tens. So now we can do decimals. That means that we can do $1.25. I don't know what you can buy for $1.25. What can we buy for $1.25? Large fries if you have the app. I don't know. What else can you buy from $1.20? A candy bar? Maybe a candy bar? Hmm, maybe. Um, Yeah, energy drink. Hey, yeah, an energy drink from the Dollar Tree, a small one. Yes, a small one. So so what we're doing here is if you notice this is the cents, right? So if I had 40 cents, right, this would be $3.40. So then we can do here $3.45. When we look at it, we have our ones or tens, but notice, right, we have our ones or tens. This is 11. We have this is 100, 111. And then if I did this is 1,111. If I had this is 1,131. Oh, okay. So I guess we're ready to, let's do a little bit more. I do have a maze that we can go through. So this maze is what we need to do is we need to read the abacus, and after we read the abacus, then we can follow the maze and then go to our end. So if we're ready, what number do you think this is? And this is another activity that I created. And it's to help understand how to read the abacus. So in the chat, thank you so much, Alex, for the heart me. In the chat, what number do you think this is? And I have to be calm. Oh, Rocio, let's see. Almost. I'm sorry. What I should have done is I should have done this. I should have done is this is my abacus, and it looks like this, and then this. So what we have is 5, 6, 7. Hopefully, there's new. Hopefully, the new has questions. Know these questions. Yeah, exactly. Yes. Thank you, Pickle, and Taken by Storm and Mandy, because it's 7, 5, 6, 7, 0, and then 6, 5, 6. So we got to find our, and then we're going to the next one. So this is our next one. What number is this? Rocio, did that make sense? You're close. You're very close. But the top bead, if you notice, the top bead will always be the top bead will always have a value of 5. So when we look, I have this number, right? 500. Yes, exactly. Thank you, Audrey. Yes, yes, Rocio. So it makes sense, right, Rocio? So we have 590. How do we have 5? This is 500, and then this is 90. 5, 6, 7, 8, 9, and then this is 0. I I need all this one Kit Kat. This is nice. All right. So we have 590. Now we have this question. This not a, is it a question? It's a question. What number do we think this is? We have this number. and then this, and then that. So, wait! Oh my god, I just joined last question. I'm so happy. Yeah! On the last question. It's easy, right? Simple to use, easy to understand. Yes, thank you, Rocio. Almost, Mandy. Because, yes, we have one. 1, 2, 3. This is 300. And then this is 1. This is a 10. And then we have 2. So when we look at it, 312. Okay, good, 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 good. Right? Easy, simple to use, easy to understand. And the biggest thing is just understanding that we're learning something different. We're learning something new. Um, and it's just a different way of looking at things, but it kind of mimics the way we write. So if I had this, what number do we think that is? 51. You're on a roll. Thank you, Zorburn, Rocio, 51, Audrey, almost. Audrey, this would be a 5. So all the top beads is a value of 5. That's what that means. Value of 5. All of the bottom beads is a value of 1. So when we look, we have 1, 2, 3, 4, and then we have 5. No matter what, this is 5, and then we have 6. Why? Because it's a 1, 5, and a 1. And then we have this. This is 5 and a 2. So this is 7. And then we just count. 5 and then 8, right? 5 plus 3 is 8. And then we have this. 4 plus 5. 4 plus 5 is 9. Yes, thank you guys. Thank you so much. 51. Thank you for the hearts. Okay, so now we have this question. What number do we think this one is? Da, da, and there. There we go. What number? Wow, yeah, Oak. Good job. Rocio, Dean, Pickles, Mandy. Right? This all makes sense? So what we're doing is we're just learning how to read the abacus. When we get comfortable with reading the abacus, then we can go further into adding and subtracting, multiplication, and division. Good. So we have this fun. We have this one. That's easy. Whoa. Yes, Audrey. Thank you. Who else? Thank you. Hey, Dumbo. That's a cool name. Your dad. No, your dad. No, your dad. Dad. No. Sorry. Your name is just kind of funny. No, the top beat is a value of 5. Because it's a value of 5, this would be 55. Yeah, you're right, Rocio. It's actually 550. Why? Because when we look at it, we have our ones, our tens, our hundreds, our thousands. So when we look, well, maybe I should move this down a little bit. When we look, we have like that. So each column is a place value. So 550, 550, 550, 550. That's what it is. 550. Yeah. I'm sorry. I keep seeing your dad. It's like, great. Your dad. Sorry. Okay. Okay. We have that. Let me see if I could do this. What if I did that? Would that be better? But we can't use it as a crutch. We're just going to use it for right now. So we do this, and we do that. What number is that? Oh, good, Audrey. Why did they never actually taught this in school. So we have 3, we have 8, 3, 1, 2, 3, we have 8, 5, 6, 7, 8, and then we have 1. Yes, thank you. My sleeper Asian agent is coming by out due to the abacus. Hopefully, oh yeah, sorry, 5. There we go. There we go. Okay, what's the next one? This one's easy. They should have, right? I know, right? They should. But they're using other manipulatives, and I'm a little bit salty on that. Yeah. Oh, good. Thank you, Dumbo. Thank you, Rocio and Mandy. Yeah, I think so, but they're using other manipulatives. I'm like, why are you using those ones? This is the forgotten tool. Thank you, Zorbone, Burn, and Sweet Kraz. Cool, cool. Okay, cool. So we have this number, and now we're over here. We have this, that, and then that. Why are you in the middle? Ooh, that's a good question. The reason why is because I have this label. This is my dot indicator. This is my ones indicator. It's like a little label, and it tells me that this will be the ones. So when I read it, I know that this is my ones, and then I have my decimals. So then I can actually have money. I can actually exchange my money. So then, yes, exactly. 913. 5, 6, 7, 8, 9. This is 1, and then this is 3. 1, 2, 3. And notice I have another dot indicator over here. Hey, Audrey, welcome back. Good morning. So if you notice, I have this indicator here, so I can actually shift. It's all about perspective, right? It all depends on how many numbers I want to use. So if I really wanted to, I could start from here, but I like to start from here because I know my numbers are big. Great. Thank you so much, Audrey. Thank you, guys. Oh, there we are. We're going this way. And this one, thank you, Manny, and Sweetgrass. Okay, so we have this, and that. No, Rocio, that's so funny. No. So it's five. Yeah, it's five. Because why? Because it's five and then three. One, two, three, and then another five. Five, one, two, three. Yeah. Wait, none of them are correct. I know. I did the beginning color and then I'm slowly taking away the color. Don't rely on the colors because it's all the same. Yes, 538. Why? Why do I? Why? Why? Because when we use a different abacus like this, we don't need to rely on the colors. So here's my other question, right? So when we do it, we can do this, and that. There we go. Yeah, see, Rocio. Actually, not seven. It's eight. Five, six, seven, eight. Yeah. Because why? We have five, six, seven, eight. Now, the reason why I didn't color it in is because in my workbook, it's not colored in. So then if you work through it, you can color it in. Five, six, seven. And so that kind of helps, I'm slacking. No, you're not. I just want to make sure that, I want it to be an interactive maze. So, oh my God, that's it. One more. We're on our last one, and then we're gonna start working on the abacus. We're gonna start learning how to move the abacus. That's the next one. Hi, Christina Stang. Yes. Oh, is it? Five, six, seven. So we have seven, we have five, and we have four. There we go. Yes. Learning to read the abacus in 20 minutes is not my bucket list, but we are here. you know? you know, I actually do midnight mass, and people are voluntarily learning how to do the abacus in the middle of the night. So you're not far. You're not wrong. Just saying. Yeah, like I'll be on at like midnight or whatever, or I'll be on at like 11 or something. And on the East Coast, it's like 3 in the morning, and I'm like, why are you learning abacus? Why are you learning math in the middle of the night? I never right. Oh, it's no, but you know what? The abacus is easy, simple to use, and easy to understand. It's gonna get better. It's gonna get better, and I'm gonna. It's gonna get better. But you're absolutely right, Nikki. I think it's hilarious. I think it's hilarious that people are like, oh my God. And you know what? Honestly, oh, thank you, Audrey, for the heart me. Honestly, I didn't think adults would find it interesting because I was actually gearing towards young kids. I was looking for like parents and stuff. But then as I started going more lives, there's a lot of like old people, like old, like, older than 15, and you're all interested, and so I'm actually in the process of producing or publishing a book for introduction to abacus for adults. I'm 42. You're so young. I'm yeah, I'm up there. I'm up there too. So, but I think it's funny. I think it's so funny. And then that was the thing. The reason why I was going to go that route was because it's like brain gymnastics, right? So it's like Sudoku, crossword puzzles, what else? Crossword puzzles and word searches. When I was a kid, the Chinese laundry would have a block and they didn't have a register. They use this. You know what? That's interesting. That's what this one is. They probably use this one. Now, what's the difference? The difference is just the amount of beads. So this one is the Chinese abacus, and this one is I'm sorry, this one is the Chinese abacus. This one is a Japanese abacus. Yes, yeah, it works very similar. But the Japanese saw it and they're like, you know what? We're gonna come around and make it more efficient. So they made it more efficient. But I'll show you. It works exactly this. It works very similar. So, excuse me. It works very similar. And so what it is they are counting 1, 2, 3, 4, 5. But notice on the abacus, on the Japanese abacus, we have five. We have this. This is five, right? We know that this is five. Now, what's going to happen is in the Chinese abacus, we have to do an exchange. Because we have 5 here, they have to do this to do an exchange. But we don't need to do this on the Japanese abacus. On the Japanese abacus, we just, move that as that's a 5. So then we count 6, 7, 8, 9, 10. On the Japanese abacus, this is 10. However, because we have the 5 here, we have to do an exchange. Excuse me, there's my exchange. This is 10. But now this kind of breaks my brain. Why? Because now we're no longer using it as a place value. We're not using the place value like we talked about, right? We don't have our ones because now we have 10. So then you have to do another exchange. This exchange is from here to here. Now it makes sense, right? Now we're using the columns like a place value like we're supposed to. That's why it kind of breaks my brain when sometimes we're doing the Chinese abacus. But I don't teach the Chinese abacus. What I teach is the Japanese abacus because I think it's the greatest thing. I think it's the greatest thing next to sliced bread. So when you look, this is 10. And so on the abacus, we have 10, and this will always be 10. But on the Chinese abacus, you'll notice that there's many ways to do 10. There's 5 and then 10. Or we could do 10, or we can do 10. And it's like, that's a lot of ways to read 10. But I like it. I like the Japanese one because it's more efficient. There's a lot of trading that happens, but the formulas work relatively the same. Yeah. So, anybody else have any questions? If not, we're going to continue on. Oh, thank you. Okay. So, anybody else have any questions? We're going to continue on. But thank you, McTarf, for that information. I never knew there was different apps. Yes. Yes. There's another one. There's the 10 bead one. I don't have a 10 bead. I don't know I don't know if you knew that there was a 10 bead one, but I'm going to use these blocks to represent. So there's a 10 bead one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's a 10 bead one that looks like this. Wait, I just joined. Can you explain? Oh, thank you, Alessandra. Yes, I will explain. So there's a 10 bead abacus, right? That goes like this. And then you can, move it. So there's, 1, 2, 3, 4, 5. You could do it. But if you have a 10 bead one, you could still modify it. Modify. But if you don't have it, then I mean, yeah. Let me know if you have a 10 bead abacus. We can modify it to make it look like the Japanese abacus. I think it's brilliant, but yeah, you can use what you have. So, Alessandra, thank you so much for the comment. So, what we're going to do is we're going to read the abacus. When we read it, it goes 1, 2, 3, 4. Because this is a value of 4, they're touching the horizontal bar. Because it's touching the horizontal bar, these are being counted. Now, if you notice, this is 4 and then this is 5. After 5, after 5, you'll notice that I don't have any more beads. What do you mean I don't have any more beads? I have plenty of beads. Why? Because we know that this is 1. But when we add the 1, right, we have 1 to the horizontal bar. We add the 5. This is 5. Now we have 6. So we have 2. We've done 2 before. And then we add the 5. Now we have 7. I grew up in the bakery that invented the sliced bread. Whoa, how I popped in now, Risa. That's funny because I use that a lot. I use that terminology. This is the greatest thing next to sliced bread. So, Alessandra, when we go 3, we know 3. 1, 2, 3. But then when we add the 5, right, now we have 8. So when I look at it, I go like this and we have 8, right? And then we have 4. We did have 4. We had 4 before, right? 1, 2, 3, 4. And because we had 4 and then we add the 5, now we have 9. Easy? Simple to use. Easy to understand. That's hilarious, Risa. Okay, so then after 9 is what? Is 10. Well, what does that mean? Well, if you notice, 10 looks exactly like 1, but just in a different place value. So when we look, we have 10, 0, and a 1. 0 and a 1. So what we're doing is, aha, you popped up on my FYP again. Again, who would have thunk it? That's great. So when we look, right, we have place values. We have our ones, our tens, our hundreds, our thousands, our 10,000. And that's what we're doing is we learn how to read the abacus. Now what we're going to do is we're going to learn how to move the beads, right? When we learn to move the beads, that's what this is coming in. So so it's a little bit about preschool, but don't be sad. Preschool, I just meant this to be preschool because we're talking about the relationship of the numbers. We don't need to worry about the relationship of the numbers. But the idea here was to read through and understand the how the beads work, how the beads match the number. So now what we're going to do is we are going to do some adding and subtracting. Use a marker. Oh, I'm sorry. Use a marker to put the dot on the bar so we could see the decimal place. No, because then the problem is the decimal place is going to get confusing with my indicator. So if I did this, if I did that, then it gets confusing. So I don't do that. Because the problem is if I put it here, and then if I use my ones here, then I'm going to put another dot here. So it wouldn't make sense. Does that make sense, McTarf? But yeah, it for now. I mean, you would have to just. This is my ones indicator, and we need to just understand that. Anyways, so when we do this, we have 5. When we have 5, I'm going to add my bead. And then what if you notice that we're going to focus on the add-in? When we focus on the add-in, we don't on the Abacus world in Abacus world, we focus on the add-in. We don't focus on the result. So what happens is we got to do a little bit of a mind shift, right? So when we read it, we're going to move the one bead. Now it doesn't matter if it's this bead or this bead. It doesn't matter if it's this bead or this bead. You want to just move the one bead. So now if I move the one bead, I have the 5 and I add 1, now I have 6. So does that make sense? When we read, right, we had 7, this is 7, we have 7, 5, 6, 7, and then we have 1. When we add 1, we're only moving the one bead. So what we're doing now is we are learning how to move the beads. The reason why is because we want to see it. When it's not very often we see how to move our beads. So that's how we start. We start with understanding how to move the beads. And notice it's very similar to when we count. We have our 5 and then we have our 2. So we have 2, 1, 2, and we move them up with that. And then after 2, so notice I'm going to the horizontal bar when I add. I go to the horizontal bar when I add. When I am subtracting, I want to go minus. I need to take it away from the horizontal bar. So that's the interesting thing about school is that now we're teaching the kids to go to I'm sorry. In school, in mainstream math, students have problems with understanding what subtraction is. But in Abacus, it's really quite easy because why? Because we know when we take away, we're moving away from the horizontal bar. So we know physically and tactile what we're trying to do. So here is 5. We have 5 and then we're going to add 3. We'll look at that. It's 8. We've done this before. So but now we're doing it in a math form. So this is 5 and then this is 3. We just move the beads to move 3 beads up. And then as we go through, we have 4. Now notice when I have 9 and I take away 3, I'm taking away 3 beads, 1, 2, 3, and I move it away from the horizontal bar. When I add the beads, when I add 3 beads, I'm going to move it to the horizontal bar. So that's about moving the beads. So after we do 4, we plus the 4, we need to know we added the 4, now we do the minus. So we're all subtracting the minus, and I've showed you how to do that. So when I have 4 and I want to subtract 1, I'm just moving away the 1. So when I have 9 and I just need to take away 1, I just need to move the 1 bead. Does that make sense? Anybody have any questions? Let me know. Thank you for the recommendation, McCaff. But then that's what I'm thinking. Like, I don't think it would make sense because there would be too many indicators. Sometimes it's best to not have too many indicators because I know that this is going to be my ones, and then after that would be my tenths. So we have 3. We have 3, and then we have 2. This is 2, and we take away 2. And then, okay, so we've done with that. Now what are we going to do? Well, we got to do the 5. We got to do the 5. We're going to do the same thing. We add the 5, goes to the horizontal bar. And then when we minus the 5, we subtract. Alex, it's a sign to learn. I just came back from my live because my phone died. Oh, so again, what we're doing is we're adding down. We go to the horizontal bar because now it's being tracked. And what we want to do is we want to add the 1. But the focus is to understand how to move the plus 5. And then after plus 5 is plus 6. So I have my question is 1, and then I want to add 6. All I got to do is add the 5 and add the 1, and I bring it together like this. When I need to subtract, I need to move it away from the horizontal bar. So that's the movement of the beads. So when I add 7, I'm adding 5, 6, 7. I bring it to the horizontal bar, and then when I subtract, it's minus the horizontal bar. When we do 8, it's to the horizontal bar, and then when we subtract 8, it's minus, right, moving it away from the horizontal bar. Right? Are we all right? Make sense? So that is a little bit about moving. And we understand that when we do this, uh, we can add the 5. So then in 9, there's not very many questions with 9. You have the 9 and you take away the 9. So taking away the 9 and adding the 9 is kind of the same. Thank you, Danku. So anybody have any questions? Questions? Okay, while I go through. Nope. Yep. Okay. No questions? Not even happy Sunday. Hey, happy Sunday, Babble. No questions? I am not happy. Anyways, no, I love questions. Please let me know if anybody has any questions. So I made this and I'm going to put it on my TikTok shop and I'm really quite excited for it because somebody asked for it and I was like, you know what? Okay, fine. I will make it. So the questions is what? The question is what happens when we don't have enough beads? What? When is it to a point where you have not enough beads? Here is the question. My question is 4, let's do 4 plus 4. Now, if you notice, 4 plus 4 is not, we don't, in the abacus world, so far I'm observing. Okay, good, McTaff. So far, we have been doing when there's enough beads. The question is there enough beads? Yes. It's just like Bob the Builder. Can we do it? Yes, we can. But now it gets to points like, can we do it? No, we can't. So if we can't, what are the scenarios that we can't? Well, in abacus world, I'm going to start coining that too. In abacus world, we don't memorize doubles. So you notice I have 4 plus 4. 4, and then notice I don't have any more beads to add the 4. If I don't have enough beads to add the 4, what am I going to do? In abacus world, I'm going to make a little thing. I'm going to make it a little thing. Abacus world. Okay. We are teaching children. We're teaching children this. We're teaching children the concept of how to make a 5, which is great. It is fantastic. But in abacus world, we actually level it up. We actually make sure we utilize the 5. We do not have any add the 5 and minus the 1. Yes, Risa, thank you. What we're going to do is we're going to utilize the 5. We don't want any free loading numbers. So what we're going to do is we're going to utilize the 5. What does that mean? Well, this is the concept that we have. And what we do is we have this 5 to utilize, right? But this is too much. So what we're going to do is we're going to add the 5, just as Reese said, and then we're going to take away the 1. So my final answer is 8. So now I don't memorize that 4 plus 4 is 8. Why? Because that's only one way. Whereas 4 plus 5, 4, here's my little worksheet. So if I have my 4, right? And what we want to do is now we know a little bit about algebra. Why are we doing this? The others to understand this is how we're going to utilize the 5. I'm sorry, how to utilize the 5. So what I'm going to do is I'm going to do 4 is equal to 5. Notice that this is not balanced. Because it's not balanced, I want to minus the 5, just as Risa said. So why am I doing that? Because when I have the 4 and I'm adding the 5, I'm now given directions. So here again, right, I have 4. And I'm going to do is I'm going to add the 5 and I'm going to take away the 1. Now you could do it again for another scenario. Whereas learning in school, we teach another strategy. What's the strategy? Doubles minus 1. I'm like, why am I learning another strategy when you can learn one concept? This is the one concept that we're teaching the children. Now we can utilize it and make it more versatile. How does that look on the abacus? If I have 3, and I want to add the 4, notice there's not enough beads. Now the question is can we do it? Well, we have to be able to utilize our beads. So we got to do plus the 5 and we're going to take away the 1. So my final answer is 7. Does that make sense? So again, we don't need to memorize our doubles. Why? Because we have this concept that we are being ingrained. This is ingrained. This is one of the fundamentals that we're teaching students. So why do we just teach them why do we just teach them how to use it once when we can make them teach it, when we can teach them to use it multiple times? Right? So now we can use it again. So if I have 2 and I want to add the 5, I'm sorry, I add the 4. There's not enough beats to add the 4. So what do? I plus the 5 and minus the 1. And now I just made it more versatile. Hello, Hannah. Thank you so much for the follow. So now I just made it more versatile, right? Learning how to use this is a great concept. But now when we level it up, now we can make it more versatile. What happens? Well, what happens is we have another one. Oh, oh, I like this. It just laminated it too. Okay, good. So, well, okay, can we only do it for the 4? Well, no, you can do it for the other 2 pairs. Let's take a look. So when we have the 3, right? How does it work? Well, if you notice, I need the 3. I want to add the 3. If you notice, let's do 4 plus 3. That's the question. 4 plus 3. If I add the 4 and I need to add the 3, the reason why it's interesting is because now I have a constraint. And because I have a constraint, how do I work with it? My constraint is my 3. I don't have enough beats to add the 3. I know to make a 5, it's 3 plus 2 is equal to 5. So what's going to happen is I'm going to isolate my variable. I have 3, it's equal to 5, right? But 5 is too much. So I need to minus the 2. Now we have directions. Thank you, Risa. Thank you. So we have the 5 and we take away the 2. So my final answer is 7. Risa, you know how to use the abacus. That's fantastic. Did you learn how to use the abacus, the Soroban or the Chinese abacus? Or do you just know it? Because it's really common, right? It's logical. But that's the thing. Oh, sorry. I forgot. Right? You're teaching me. Ah, okay. Good. Okay, good. Because you sound like you really know. But I'm really enjoying this. Thank you so much. So again, if I do 3 and then minus the 2. So here, I pick it up fast. Yeah, you're picking up really fast. But it makes sense, right? So we're not memorizing doubles. So here's 3. When I add the 3, notice I don't have any more beats to add the 3. So what do I need to do? I need to utilize the 5. I want to stay with the one column. So I plus the 5 and I take away the 2. So my final answer is 6. Yeah. So then, oh, thank you, Danku, for the heart me. So then what happens? Well, remember, right? We know how to do the 3. We can do the 2 and we can do the 1. It's all the same. So so understanding this concept, we can now compound our information. We can compound our math skill. Now, what happens after this? Well, after we know how to add, we'll know how to subtract. So one of the things to do adding and subtracting is the minus. Same thing, but this way, now we're having the minus is the negatives. So when I do why am I doing this one? Well, if I look, that's fine. We have 7 minus 4. When we do 7 minus 4, it's the same thing. I have 7 on my abacus. My question is I need to minus the 4. When I minus the 4, what do? I need to isolate, oh, not that one. I need to isolate my variable. I'm going to isolate my variable. This is the variable I need to isolate. When I isolate this variable, I got to move this over to here. Why? Because look, if I do 4 is equal to minus the 5, this is too much. So what do I need to do? I need to add the 1. Right? To make the 4 by itself, I need to add the 1. So now I have directions again. When I want to take away the 4, all I have to do is minus the 5 and add the 1. So my final answer is 3. Thank you for the hearts. Does that make sense? So what we're doing is we're again utilizing this concept, but we did it twofold, right? We learned how to do it one way with the 4. We learned how to do it another way with the 3. And now we're doing it the minus. Looks very familiar, doesn't it? So we could do the same thing with the minus 3. Minus 3 is equal to minus the 5 plus the 2. So when are we going to do that? Same question. Let's do 7. 7 minus 3. 7 minus 3, there's not enough beats to take away the 3. What do? I have my 5. Minus the 5 and then plus the 2. This is hurting my head. I just got here. Hey, Yanni, that's too bad. Go get, I don't know what to say about that. right? So what are we learning is we're learning how to utilize the math. We're learning how to utilize the abacus. Right, Dunku? Like if it hurts your head, then maybe you should leave. I don't know. I don't know what to say about that, right? If you want to learn, then I can always review. She's doing specific because is she doing it like this specifically because she's using the abacus? Yes, Yanni, I have an abacus, and this is very specific to abacus. Thank you, Nanku. Yanni, is the question that you want to learn, or is the question that I don't know what the question is? It's okay. So when we learn it, right, we have one way, but in abacus we compound our information. So what did we do? Is we took this information and now we made it better. We made it versatile. Okay, Yanni, I will stop giving you a hard time. All right, Yanni, if you're still in here, please let me know. I'm going to tell you how to count. I generally don't understand what the abacus is being used for. It's being used for we can add, subtract, multiply, divide. Usually it's used for visualizing addition, subtraction, multiplication, division. So if you think about it, usually it some people would be like, well, you can use a calculator. It's like, yeah, you could use a calculator or you could use your brain. But the idea is for kids, you don't really want the kids to use a calculator, right? It doesn't make sense. Usually, abacus is introduced to young children, probably about I'm trying to introduce it to them at 3, 4, and 5. Um, and so it's nice to be able to see, and we have our difference, right? We have our differences because we use blocks. These are the blocks that we use for school. And so we're using many math manipulatives, but nobody really uses the abacus. So the argument is this is the forgotten tool. Whereas, why do we need to use it? We need to, well, how are the kids going to learn? Well, the adults need to learn it, right? The adults need to learn it in order to explain to the kids. Do we use it now? You can use it, when you just do regular math. If you already know how to do mental math, that's great. This is just another way of doing arithmetic, if that made sense. So it'd be the same thing as like, well, why do we do Sudoku? Well, it's only numbers from what 1 to 9, but you do it to do a brain gymnastics, and abacus also is providing that brain gymnastics. And so, like, why do we do crossword puzzles and word searches when we're old? Because it's just fun. So the people that are coming in and they're learning how to read the abacus, it's enjoyable, and it also helps to keep the brain active, if that makes sense, Yanni. Oh, sorry. So when we use the abacus, we're using it to track our numbers, and we can visually see it. Yes, thank you, Danku. When you see people shaking their hands, yeah, 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 exactly. Yeah, no, Yanni, I'm sorry. I'm just being, yeah. So let's do a review. So here's the review, and thank you for letting me know that you're still here. Thank you. I do appreciate that. So we're going to count on the abacus, right? To do it, we're going to do 1, 2, 3, 4. Notice that all the beads touching the horizontal bar is considered counted. So we have 4. None of these columns are being counted. These are all zeros. Yanni, let me know if you have any more questions. I will be happy to explain it to you. So after 4 is 5. Now we have the value of 5. All the top B will be the value of 5. So if I did this, this is all 5. But now when I do this, this is all 0. When I have 5, and then I can do 6. Notice if I take away the 5, I have 1. So now, thank you, Scott. Now, if you notice, I'm making it more versatile. So if I have 1 and I add the 5, I now have 6. I have how much does one cost? This one specifically on my in my website, link in bio. It is $10. But in the TikTok shop, I'm trying to figure out the TikTok shop. I am selling my books as well, Yanni. So we have 5 and then we have 6. Notice that when I have two and I add the 5, now I have 7. I have 3. Remember I had 3. I add the 5. Now I have 8. This is 8. So now when I have 4 and I add the 5, now we have 9. So because we have 9, we can do 10. After 10 is the same. So it's the same. It's just a different place value. So when we look at the different place values, we have our ones, our tens, our hundreds, our thousands, our 10,000s. As we go through it, this would be 11. And now Abacus, the way we look and read the Abacus, what about the big Abacus? You can get it at Daiso. This one? Or you're talking about the big one? Or you're talking about the big one, right? Yanni, did that make sense? I just want to make sure you understood. I've seen this before. Hey, Arnell. Yes. Watch this video. Wait, I'm sorry. I've seen this before and watched videos on this. I'm in school as this would have been helpful. Yeah, it would have been helpful. Oh, yeah, this one you can get it from the, from the other, you can get it from Amazon. This one is, I don't know, it's like 100. You know what? If you DM me, I can give you the link. Um, so this is the teacher's abacus. This is the student's abacus. And so if you notice, the reason why obviously is because they can see it, across the room and stuff. This one just happened to be given to me from a retired abacus teacher. But yeah, thank you, Yanni, for letting me know. So let me know if you have any more questions, and we're going to continue on with adding and subtracting. Um, what are the differences in the bigger ones? The bigger ones, well, this one is it's stationary, right? So if you notice that you can move the beads up and down and they don't move, right? They stay where they are. Whereas on the student one, if you move it, the gravity falls because it's very similar. Now, if you're talking about this one here, it's all about the digits. So this one is a 7 column abacus. This one's a 7 column, and then this one is a 13 column abacus. And the reason what they're different, the only difference is not it's not the colors, it's the size, because size matters. The reason why is because if you notice, I only have two labels, one here and one here, and so Danku. Oh yeah, we could do multiplication. Um, before I continue, let me finish my thought here. So if you notice, this one has one, two, three, four, five. There's five different sections. So if I started here, this would be my ones, my thousands, my millions, my billions, and my trillions. So what we can do is we can have our big numbers here, and this is a 13 column abacus. You could start in the middle and then have a lot of decimals, or you could start in the front, right? Start in the middle, and you have a lot of big numbers. So then if I started here, then my number would be very small. But if I started here, then my number would be very big. But then if you wanted to track the national debt, you would have to get a 23 column abacus. This one specifically is made out of bamboo. I'm sure you could still get it, but I don't know if it's made out of bamboo anymore. This has been with me for more than 20 years. I've been teaching abacus for about more than 20 years. And so this one is made out of bamboo. This one's relatively new, and this one you can get from Daiso. You can get it from Daiso, and I'm going to try to figure out how to get it into my store. But if you're looking for this one, you can get it from here. You can get it from here. You want my books? That's me. You can get that, or you can get this one from my website. I do sell this on my website, and I'm trying to get it on my TikTok shop. Yeah. So let's do some. Okay, we'll do really quickly, Donku. Um, but make sure but I want to make sure that nobody's head is going to be hurting. Don't blame me if somebody's head's hurting. I'm going to have to blame Danku if your head's hurting. All right. So, yes, I appreciate the humor. I'm happy people are okay with it because it would be sad if you don't think it's funny. I'm just here to be I'm just trying to be funny. That's all I am. I think it's funny. I think it's fun. Everybody's here. Okay, thank you guys for joining. Thank you guys so much. Okay, so what we're going to do is so the first thing we're going to do is understand that we do not memorize anything higher than 9. What? What does that mean? Well, in I don't know why we tell the kids that they have to go all the way to 13 or 12, right? 12 times 12 is 144. I don't know why we need to do this. In Abacus, we actually use this thing called distributive property. I don't know if you understand, not understand. I don't know if you knew the terminology distributive property. Yeah. Oh, yeah. So oh, sorry. We actually do this all the time in Abacus. So here's my question. If I did, let's do 25. So we'll do something easy. 25 times that by 5. Now, what we need to do in Abacus is we need to understand where are we going to put our number. To put our number, we need to count our digits. So when we count one, two, three. We know that we're going to start in the third column. This is just a process that we need to do. So, hello, Manny, welcome. So, what we're going to do is we're going to have a conversation with our questions. Do you have an order of operations? I have an order. I have an order of, um, like an abacus framework that hold on. Oh, here it is. I have an abacus framework, but not we don't do order of operations. How many years of experience you took at visualize the abacus in your head and do math? If you practice, like you would have to practice a lot. It's just like playing the piano, right? Like how do people play the piano? It's the same thing. So as long as you play the piano, I mean, probably what, maybe a couple of years. I don't know. I do have a framework of adding and subtracting, but I don't have an order of operations prodigy. So when I look, my questions, but this is addition subtraction framework, and we didn't talk about that, so I don't want to confuse anybody. So the first thing we're going to do is understand that we are going to do three, one, two, three, one, two, three. Now, when we do it, this is the distributive property part where we go from here to there. This is also new math, but in new math, they do what do they do? They do 20 times 5. But we don't do this. What we do in Abacus world, we do 2 times 5. So 2 times 5 is equal to 10. That's how we do it in Abacus world. So Abacus world, we do 10, 1, and then 0. I'm moving my finger and I'm here. So then the next thing we're going to do is 5 times 5. 5 times 5, 5 times 5 is 25. Ooh. So all I got to do is add the 20 and add the 5. So my final answer is 125. Easy? So that one was easy, 125, right? But what we did is I'm lost. Oh, okay. So the first thing we're going to do, Arnell, we're going to count our digits. We have three. One, two, three. So when we look, we know our answer is going to be here, right? Our question, Arnell, is what? 2 times 5. When I multiply it, because I'm doing multiplication, what is 2 times 5? 2 times 5 is what, Arnell? 10. Thank you. So when we add 10 to the abacus, we're going to add the 1 and we're going to add the 0. Does that make sense? So when we add the 1 and the 0, we add 1, we add 0. Notice I'm not going to say 20 times 5. I'm going to say 10. 1, 0. So whatever the number is, I'm going to add it to the abacus. I add my 1, I add my 0. Because it's a 0, you don't do anything. So the next question I have is 5 times 5 is 25. I'm sorry, right? So then I add 20 and then 5, and you just go down the column. Does that make sense? So when I add 25 to my abacus, I'm going to add 20 and then I will add my 5. So my final answer is 125. Did that make sense, Arnell? Yeah, yeah. So I also realized I talk a little fast and I forget what it's like to look at it as a beginner. So thank you so much, Arnell, for letting me know. And again, we could do it for all the questions, right? That's neat. Yeah. Thank you, Donku. I mean, we could do it for more questions, right? We can do a simple addition, a simple multiplication. The reason why is because we didn't go through adding and subtracting. There's a bunch of formulas that we need to know, right? We know how to make a 5. Then we need to learn how to make a 10. When we learn how to make a 10 and we can do that now, we can start going into bigger, more complex, hairier multiplication questions. So here's a bigger question. If I had 93 times that by 7, right? Okay, so 93 times, it's again the same thing. The process is the same. I need to count 1, 2, 3. So I'm going to count 1, 2, 3. When I count to 3, my answer is going to be somewhere around here, right? So now the question is what? I go from left, I do the left first. So my question is 7 times 9 is what? Arnell, what's 7 times 9? Uh, 63. Yeah, I just had a brain fart. Sorry. 60. So I'm going to add 60. So I add my 6 here and I add my 3 here. So notice how I add. I don't say edit, remove. I don't say 630 because why? Because the abacus does it for me. So I don't need to worry about the hundreds. Does that make sense? So my next question would be what? 7 times 3. 7 times 3 is what? Is 21. So this is where we needed to really know our addition. I want to add the 2. Can I add the 2 here? No, I can't. Do you remember how to add the 2? Thank you, Arnell. Thank you so much, Arnell. Okay, good. I'm on the right track. Yeah, sometimes I get a little brain fart when it comes to like multiplication. So when I add, right, I'm going to add 20 and I add the 1. How do I add 21? I don't have enough beats to add the 2. What do I do? If I don't have any more beats to add the 2, what do I do? Move the green up? Move the 5 down. Yes, Karina, use the other side. No, we're not using the other side. We need to go through and understand that we can utilize this 5. We need to drop the 5. Exactly. So the formula is plus the 5 minus the 3. Right? Yes, Sophia, because we've learned this concept. When we learn the concept, right? We've taught this had the kids. Now when we went through it, so what we're going to do is we're going to plus the 5 and I take away the 3. So and then I'm going to add the 1. I need to add the 1 and I add the 1. So what my answer is 651. Yeah. Add the Oh, wait. Did I do that wrong? 63. Add the right, okay, got it. Right? 63, it was 3, and I need to add the 2. Add the 2 is plus the 5 minus the 3. Yep. And then the 1. Yep. I got it. We're good. But does that make sense? So what we did is we understood how to do the adding and subtracting, right? We did the adding and subtracting when we didn't have enough. So that's why multiplication is just a faster way of adding. But we still utilize the information. We still utilize when we added and subtracted, right? We can do more numbers. So what happens when we have our yeah, let's do some more. Um so then the other question is like what happens when there's two digits? So this is a very common question for school for abacus. 73 times that by 48. Well, how does that going to work? It's the same thing. It's the same process. But again, we're talking about distributive property. When we do distributive property, what are we going to do? Right? We got to count. Again, we got to count where our starting point is. 1, 2, 3, 4. So 1, 2, 3, 4. We're going to start over here. Now, how do we do this? Again, remember I said left first. So we go left to right. This is my left. This is my left. So we go left first, right? We say 48, not 840. We say 73, not 730, not 370. So my question is 4 times 7 is Arnell, are you still here? Thank you, Angel. What is 4 times 7? Thank you so much. So, okay, so now what I'm going to do is I'm going to add 28. 1, 2, 3, 4. I'm going to add my 2 and I add my 8. So I'm going to add my 8. Notice I say 28. I don't say 40 times 70 is equal 200, 2,800, right? That's what new math is. What we're doing is not new math. What we're doing is forgotten abacus. So what's the next one? Where the next number is here, right? We still got to go from left to right. So 4 times 3 is 4 times 3 is, thank you, Arnell, 12. So I have my 1, I add 1. Do I have enough? Yes, I do. I'm going to be Bob the Builder. I go, yes, I do. I have 1. And then I add 2. Oh, I messed that up. There we go. I add 2. So now I'm done with the 4. When I'm done with the 4, I have to reassess. Thank you, Primrose. Thank you, Yanni. Right? So now I'm done with the 4. I need to reassess. When I reassess, what do? I need to count it. 1, 2, 3. So what are we going to do? 1, 2, 3. Okay, this is where it gets a little bit complicated because now we're going to like some parts that we didn't learn. How do I know? Because when I do this, 8 times, oh my god, 8 times 7, is it 54 or 56? I can't remember. 56. Thank you. So 7 times 8 is 56. So we do 56. I'm here. Thank you, Donku. Thank you, Arnell. Right? I'm here. 56. I want to add the 5. Cannot add the 5. Okay. This is where we have to start learning how to do our tens. How do you make a 10? This is when we start carrying on, carrying the 1, borrowing, regrouping, trading. This is all the numbers. This is all the, what we're doing is we're going to add the 10. In the abacus world, we call it adding a 10. What does that mean? I want to add the 10. Remember, I'm going to add this 10. If I add the 10, that's too much. What do? If I add the 10, it's too much. I need to take away the 5. So my formula is plus the 5 is equal to plus the 10 minus the 5. That's the formula that we need to know. And then that's my adding of the 5. Now what we need to do is we need to add the 6. Can I add the 6? Yes, we can. Just like Bob, I'm going to add it. So all I got to do. So we're done with the 7. Now we got to do 8 times 3. 8 times 3 is... Uh-oh. What? What's wrong? 24. Thank you, Arnell. 24. This is now going into two-step equation. So again, this is when it comes to a point where you need to really know your when you really need to know your plus fives, right? Plus fives, plus tens, you need to know these formulas. Everything about adding and subtracting is all right here. This is the plus tens and plus five. So what we're going to do is we're going to plus the 2. The question is, can I plus the 2? No, I can't, right? Can I plus the 5? That's the next question. Can I plus the 5? No, I can't. So the next one is, can I plus the 2? 10. Yes, I can. But it gets a little bit more. Because this is going to be a little bit more. Why is it more? So I want to plus the 2. Plus the 2, I'm sorry, this is very confusing. Plus the 2 is minus the 8, right? Plus the 2 minus the 8. Plus the 2, plus the 10 minus the 8. Plus the 10 minus 8. Plus the 10 means 1 and a 0. 1, 0. Can I add the 1 here? No. What do? Plus the 5 minus the 4 and then minus the 8. Take away the 8. 5, 6, 7, 8. So I take away the 8. And then I add the 4. I'm going to add the 4. And that's what I did. That was a little bit more complicated than I anticipated. I'm sorry. I apologize. Usually I have better questions that are a little bit more easier. But my final answer is 8504. 8504. All right. That one, yeah. That one was a little bit harder. That one was a little bit harder because there was this thing called we call two-step. Now, what is a two-step? A two-step is when here, let's review what a two-step is. Yeah, that one was a no joke one. That one was no joke. So what is a two-step? A two-step is when we need to use two formulas at the same time. So we know how to do this. So now what we're going to do is we're going to understand how to do a two-step. A two-step is when we do 7 plus 7. Let's do that. That was a good example. This is what I was hoping to see. So now I can't see the direction. Now I can't see the direction I'm learning. Yeah, is heading. Yeah. Yeah, and the idea is to really solidify this information, right? The idea is to really solidify. Once you know this, then everything is gold. Then everything else is just procedural because what you're doing is you're calculating it in your head. Okay. So, yeah, let's go back to this one. Let's go back to what the two-step is. So with the two-step equation, we're going to understand we're going to have the 7, right? Because we have the 7, we're going to add another 7. Notice I don't have enough beads to add the 7. Remember that when we do our formulas, plus the 7 is plus the 5 minus the 3. So my formula is equals to plus the 10 minus the 3. So what does that mean? I'm going to plus the 10 minus the 3. If you notice, 10 is a 0 and a 1. So that means I'm going to add the 1 here. That's what that means. 0 and 1, 0 and 1. So all I got to do is just add the 1 because that's what 10 means. Now I want to take away the 3. When I take away the 3, I don't have any more beads to take away the 3. So what happens is what? This is where my two-step equation happens. Why? Well, if I cannot take away the 3, what's another way to take away? How do you take away the 3 if I don't have enough beads? Remember, we have this formula, right? Remember, we have the formula to minus. So when we look, we want to minus the 3. Remember, minus the 3 is minus the 2, minus the 5 plus the 2, or minus the 2 plus the 5, right? One of these two, it doesn't matter. These two are the same. This is what we call commutative property. So it doesn't matter which two, but these are the two. So when we look, I want to minus the 5 plus the 2. I want to minus the 5 and then I want to add the 2. So my final answer is 14. Does that make sense? So what did we just do? We just did this is what we call a two-step because a minus the 3 is equal to minus the 5 plus the 2, right? Does that make sense? Yeah. There's a whole so Danku, just so you know, there's a whole like curriculum to learn Abacus. It's just, jumping through and jumping ahead, sometimes it doesn't benefit. Not a lot of people can keep up. So that's why I'm always very hesitant of going into multiplication, but ultimately is understand how to do division because division actually is quite fun on the Abacus. It's actually more fun on the Abacus than it is in mainstream math because we have conversations. Yeah. Yeah, right? There was one time I was talking about it and somebody like came in and they were being rude because they were coming into the middle of my conversation. They're like, "This doesn't make sense. You're a horrible teacher." And I'm like, "You know what? You joined in at the middle of the conversation. Just sit and listen for a little bit." Yeah, I can see that. Yeah, some people are a little bit like, I don't know. So, Arnell, are you still here? Does that make sense? And Yanni, are we okay? Or have I lost people? Yeah, honestly, that helped me. Yeah. Okay, good. Right. So what we did, oh, I need to write the answer. So what we did is we did this is what we call a two-step equation. This is very similar. Wait, I hate division in regular math. Can you show a division problem? Uh-huh. Yeah, I don't like division in regular math too. And I looked at it, I was like, this is a piece of okay, if we're ready, we can do it. If we're okay, I mean, let me know, and I will take it. Let me know, and I'll take it slow. But yeah, we'll do division. Okay, let's do division. The first thing we're gonna do is understand. Okay, wait, before I forget, Yanni, Arnell, the people that are not commenting, let me know if there's anything that you don't understand. Because if you don't, then I'm going to. I love you, Steve. Yeah, let me know because I can go slower because I know I talk fast. So let me know if you guys have any problems, okay, Arnell, Yanni, and some other, I'm sorry, and B and others, whoever else is in the room. Okay, we're ready? So the first thing we're going to do, let's see. Okay, good, good. Yeah, let me know. Keep me updated if you're ever confused, because it's always good to make sure you understand, because it would suck. I would it would hate it if I was in a class and I'm like, I have no clue why we're here. You know what I mean? You guys are here for a reason, and I want to make sure that you make it makes sense to you. There's no point of being in a room if it doesn't make sense. Okay, okay, good. Let me find a let me find a question, because I want to make sure that it divides out. Because obviously, when the question is easier, right, it's easy to see. So the first thing I'm going to do, I'll be ordering an Abacus from you for sure. Thank you. I appreciate that, Uncle. You know, Don Ku, is this for you or for kids? Because I was thinking about in my TikTok shop. In my TikTok shop, I'm selling this. And then I was like thinking, oh, it's for you. Okay. Well, if it's for you, this one is available in my TikTok shop. If you want something larger, and I would actually recommend something larger, I would get this one from Daiso. I don't know where you're located, but I would get this from Daiso because it's 13 columns and it's a little bit more versatile, because you can do more bigger questions. You can't, you get, I get really restricted to do division. If I do 3 or 4 digit division onto this, it gets really, it's a little bit restricting. I would recommend doing the 13 column one just because there's more spaces. And I'll show you what I mean. I'll show you what I mean. Like, I do appreciate it. I really appreciate that you would like to buy from me. But to, like, for all intents purposes, I think this would not serve. It wasn't meant to. If you just want to stay with the if you just want to stay with adding and subtracting, then that's fine. But if you want to go into multiplication division, I would go further into it. And I think multiplication division's really fun. Anyways, so you'll start seeing, I'm going to start switching out depending on how big the question is. I'll start switching out because I don't have enough room. Just so you know. Okay, so the first thing we'll do an easy one, because I don't want and it, you know what, this is a version of long division, right? I agree. Multiplication division is where it gets fun. Yeah, it gets really fun. And because multiplication, it gets a little tedious, but it's interesting because it's like a little puzzle. So yeah, and yeah, that would be my recommendation. 23 column, I think, is a little bit overkill. I don't think you need this many columns. I think the 13 one is just fine. Depend Because how big is the question going to be really be? You know what I mean? Like, even if you did five five digits on each side, that's already 10. One, two, you know what I mean? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you could do multiplication that's 5 digits times 5 digits. Anyways, so the first thing we're going to do is we're going to understand which is the dividend and which is the divisor. This is the dividend and this is the divisor, right? Not a problem. Now, what we're going to do is, again, just like we did with multiplication, we need to know where we're going to put our answer. So we need to figure out how to find our answer. There's 2 digits as a dividend. So there's 2 digits in the dividend, right? Take away 1 digit is our divisor. 1 digit is our divisor. So when 2 take away 1 is equal to 1. My answer is going to be here. So I'm going to put my answer is my quotient, right? So I'm going to put that there. I laugh because I can't throw away anything, and I just made this little flappy thingy came from a broken plastic box that I got, but it works perfect because it's exactly what I need. All right. So what's going to happen is my answer is going to sit right here. Because my answer is going to sit right here, I'm going to use my dividend to hold my place. Because it's holding my place, now what I need to do is I need to compare. I'm having a conversation with my question. And I think that's one of the problems that we don't do in school is we don't have a conversation with our questions. What does that mean? Well, I need to know who is bigger. And I don't understand in school is why don't we do comparison? We compare all the time, but we don't do it in division. And I don't know why. So my divisor is 2. My dividend is 5. Sorry, my dividend is 5. Which one is bigger? Which one is bigger? Thank you guys so much for the hearts. And wow, there's 18 people in the room. That's fantastic. 5. 5 is bigger. Right. Thank you. I appreciate the comments because it keeps me on track. So yes, 5 is bigger. So if the dividend is bigger, you want to skip one column. That's what we do on the abacus. We're going to skip this column and we're going to go here. My answer is going to start here now, right? And I'm only going to look at one column. So my question now is we do multiplication. It's actually division is just reverse multiplication. So my question is 2 times what is equal to 5 or less? Because we only want to use the one column. We only need this one column. So my answer is 2 times 2 is equal to 4. So I add 2 to my quotient. I'm going to add 2 because that's my answer. And then I take away 4 because this is my dividend. This is where I do the minus. I'm going to take away the 4. Take away the 4 is what? I don't have enough beats to take away the 4. I know minus the 4 is equal to minus 5 plus the 1. So I'm going to minus the 5 and then plus the 1. So my answer now, my dividend is 16. So we do it again. We're going to compare. Our 2 is our divisor. 16 is not the dividend. 16 is not the dividend. I'm sorry, is not what we're trying to compare. 1 is what we're trying to compare. We're going to compare 1. This is the one we're going to compare. The question is who is bigger, 1 or 2? 2 is bigger. So when there's 2 is bigger, then we know if I need to do it, what I need to do. 2 times 1, this is not, this, you can't do that, right? You got to have the second digit. The second digit is 6. So we need to add the 6. Now my question is, what times 2 is equal to 16 or less? 2 times 8. I'm at 8. I take away 16. I take away 1 and I take away 6. So my final answer is 28. Did that make sense? How this is bizarre. Yeah. Abacus makes everything into smaller chunks. I know. It's so crazy. Like in school, we were taught how many times does 2 go into 56? I'm like, I don't know. So what do? They say, okay, well, 2 times 24 is 48. Okay, I need to do more. Okay, so then 2 times I don't know. 2 times uh 5 is 50, right? Okay, I need more, right? I need to do another one. So 2 times 26 is 52, right? And then it's like, no, I got to do it again. 2 times 7 is 54. But it's like, well, why are we doing it this way? I don't know. But this is the process of division in the abacus world. We can do another one, but I love it. I love it how simple it is. It's just a lot about the process, and now there's a new terminology. It's called procedural fluency. I'm like, I don't even know what that means. I kind of made up my own algebra that went that way too. I didn't follow the rules, but yeah, but I got the answers. Yeah, yeah. I don't. I was taught this way, and it's just like there's got to be a better way. And then when I learned how to do it on the abacus, I'm like, I can't believe why we don't teach kids this way, because you break it down into manageable chunks. The chunks are manageable. Oh, 2 times 5. Oh, that makes sense. We can do another one. This is like fantastic. But you know what? Adding and subtracting is also underrated. I feel like that should be better too. Because if I get a bigger number, like if I get a bigger number like 9937 and then plus 34, right? They're like, "Oh, how do you make a 10 out of this?" I'm like, "Why am I trying to make a 10? Why don't I just add it?" Because I know my formulas, you know what I mean? Whereas they would be like, "Oh, well, this is easier, but then you have to remember that you added the 3 here. So if you added the 3, you have to remember to minus the 3." It's like, okay, well, if I minus the 3, I'm going to minus the 3 there. It's like, you know what? It gets really complicated really quick, and I don't understand why we do that. I don't understand why we're teaching children to be more complicated. It's just break it down into manageable chunks. Oh, I thank you, Donku. Thank you. But that was one of my rants, and then somebody came in like, "You're a horrible person." I'm like, you know what? Get out of my room. Okay, we can do another one. I do the simple ones, right? Because it's easy. Because one, it's about a process, and two, it's just understanding the process, right? So when we look at it, what did I do? 56. So we can do another one. We do 74. So two divided by 74. And again, it's the same process, but it's a conversation. I don't know if Karina is still around. So I have a dividend and our divisor. I was a little scared to explain it, but as I explain it more, it's becoming easier for me to really follow through. But it took a little bit to get to this point, because when we teach the kids, we just teach the kids. But now I'm teaching adults. It's different because I have to explain, why are we doing certain things? Because that's how I learn. I learned on why are we doing it this way. Oh, right. So that's the reason why that's how I teach. I teach because I want to know why. Unlearn. Is it? Yeah. Yeah, it was a little difficult to unlearn. And then, we're going to, you know what? We're going to get into two-digit division, cuz that's what really pisses the shit out of me. Because in the mainstream school, it makes it so difficult. And I'm like, why are we doing it this way? Anyways, but we can do the two-digit one. I just have to find a nice one. So what we're going to do is, again, we're going to find our division. We're going to find our place value. So we have 2 here. So 2 dividends, right? Take away 1. So when we do 2 take away 1, right? It's the same thing. It's the same process. So we don't need this one. We can do this one. So we're going to be here. When we go here, can we do that? No, we can't do that. Okay, you know what? We'll do this. There we go. We are going to go here, right? This is 1. I could see how it'd be easier based on the multiplication example. Yeah, yeah. But I think mainstream math goes a little bit too far, because we got to do this. And I was doing research on how do other people do division. I don't remember how to do division anymore because I've been doing division on the Abacus for so long that I have to go back and I have to refresh, like, how do they do it in mainstream math? And they do it this way, and I'm like, why? This is so big. This is such a big chunk. But here, okay, but here, what we're going to do, again, we're here. This is where my answer is. So what I'm going to do is I'm going to put my dividend. I'm going to put my dividend on my abacus. So I have 70 and I have 4. The reason why we do that is just to keep track of where our answer is going to be, right? So now my question is what? My question will always go back to comparing. So when I compare, my dividend or my divisor is 2. My dividend is 7. Who is bigger? My dividend is bigger. So if my dividend is bigger, now I know I need to skip one. I'm going to skip one column, and you'll notice that when I look at it, I have enough to subtract, right? What times 2 is equal to 7 or less? So I just need the 1. So 2 times 3 is equal to 6. So I add my 3, 1, 2, 3, and I take away 6. I take away 1 and I take away 5. Thank you, Donku. Right? Oh, you can't see it. Let me see if I can do that. There we go. So then what's going to happen? Well, we compare, but we don't compare 14. What we compare is the 1. We compare apples to apples. So 2 is my divisor and 1 is my dividend. My divisor is bigger, so I know my question will be 2 times what is equal to. Hello, Lando! Hello, Lando! How are you? Um, Notice that 2 times something, it cannot equal to 1. So we need to have our next number, right? 2 times what is equal to 14? I'm ready to learn. Lando. Hey, Lando. Did you want the abacus? Um I Is it, is it for you or for your kids? Oh, okay. So 2 times 7, so I'm going to add 7. Add the 7, and so all I got to do is take away 20, I'm sorry, 14. Take away 1, take away 4. So my final answer is 37. So that's my answer. 37. I don't know if Katrina left. Karina. I don't know if Karina left. Arnell, you all right? I don't know if Arnell left. Okay. Oh, good. Oh, good. Did it make sense? I'm so happy. I'm so happy that made sense. But it makes it easy. I think it's easier this way. But then again, I also think it's, yeah. Oh, I wonder if Risa is here. Okay, good. There's no questions? Oh, okay. Yeah, I do find it better. Hey, Budget, welcome back. So, but that's the thing. That was the thing. Hello, hello. How are you today? Happy Easter, everybody. Happy Easter. Is it a happy thing? It is happy. It's a happy holiday, right? Yeah, it's happy because he's risen. Yeah. I'm I'm great. Happy Easter. Yeah. Yeah, we were just doing some division. I don't remember where we left off. But I was trying to grow. I'm trying to figure out how to get my I'm trying to figure out how to get my stupid TikTok shop onto my desktop. But for those of you who are not understanding, like, this is my desktop and I'm actually streaming everywhere. It is fantastic. I love it now. Now I can stream. I have my Facebook, I have my LinkedIn, I have my YouTube, I have Instagram. This is fantastic. So if TikTok ever gets buggy, you'll have to find me over on like YouTube or something. And I see comments too, but there's nobody there watching. Ah, do you have a business account? I do have a business account on TikTok. That's why I'm trying to sell my books. I just haven't figured out how to connect my TikTok shop to my desktop. And I think I got to figure out how to link it because I want to sell my abacus. So I have my book. I'm selling my book. So I'm selling this book and I'm selling this book as well. I have these ones. I have this book and another book. And I have these books. How much are the books? They're on sale right now. They're on sale right now. If you look at my shop, I have to go look. Yeah. In the settings on the desktop website, you need to access the seller. Yeah, but the problem is my accounts don't link up. So that's the one problem. So well, let me see if I can find my okay, so I'm here, my shop. I'm actually quite excited for all of this. I'm getting better at like So here's the thing, Arnell, if it's for you, you know what I will do, because you guys are on my live. If you buy this now, I will put the Abacus in for you for no extra charge. But yeah, it's 1780 or this one is the Who, which is 1020. I haven't figured out. Yeah. So, anyways, yeah, those are the only two so far. I gotta build out my store more. I have more books. I'm on 8 books right now. I just haven't done it yet. I gotta figure that all, and I gotta figure out how to do this. Can you access the shop streamer tool? That's what I'm trying to figure out. There's a shop streamer tool. I have to go look that up. So yeah, because like I like that I'm on my desktop, because then I can share my screen, and then you can see me. But then I can also I can share on all my other platforms. But I'll have to look that one up. Shop streamer. Oh, I'll have to look that up later. But yeah, I have to. Yeah, I haven't figured out how to connect my store to my desktop. That's what I need to do. Anyways, so that's what I got. That's what I got. Any other questions? Yeah, and then that was the other thing, is I wanted to update this one. So I have my I this is a laminate. I laminated it, and it's kind of cool. So you know how I have all my like formulas. So these are all the formulas that you need to know when you're adding and subtracting, and it goes through how to make a 5 and how to make a 10. So these are just like showing you how to do the commutative property, and then after that it goes into the actual, what do you call it, the setup, and it's laminated because then you can do it again. So this was to help parents or teachers, to show them how to work it. So then this is the idea, is like, if I need to add the 2, I'm going to isolate the 2. So I need to do 2 is equal to 5, and then 5 is too much, I need to minus the 3, and then we can do the commutative property later. Look up brand meets creator on YouTube. Oh, okay, cool, thanks. And things how to do it on. Okay, cool, thank you so much, balls. Yeah. So then the idea here was to do 2 is equal to 5 minus 3, or equals to minus the 3 plus the 5. So this was just the activity, but I think it was helpful. I mean, I do it because, and then I was like, oh, I could give this to teachers, but I would have to laminate. I would like to laminate it for them, or you can laminate it your own. Yeah, brands meets creators on YouTube. She has tons of videos on how to do things. Okay, cool. Thank you so much, balls. But yeah, and this is, I think there's 15. I think there's 15 pages. Where am I? This one. Um, where is it? Yeah, it's 15 pages. So yeah, I kind of like it. I mean, oh yeah. So okay. So anybody have any questions? We can continue on. With like adding and subtracting. Oh, excuse me. I'm getting a little tired. And we did division. Oh, you know what? Let's do the two. That's two. Sorry, 2-digit division. I'll show you 2-digit division, and and some of the processes that happen. Because in mainstream math, it's ridiculous. Okay, let's see. Let's see. Here we'll do that one. Okay. Yeah, I forgot we were supposed to work on that. But we have to be careful, because sometimes when we think about the quotient is too large, we have to do another step. That's the only thing. Um, I'm just trying to find better numbers. Wow. Okay, let's do this one. All right, let's see how this works. We have, what number? Okay, we'll do this one. 43 divided by 774. It's the same thing. Oh, see, this is what I'm saying. Like, it starts to get a little bit tight because now here, oh, we could do here. We can do here. We could still do it. So 1, 2, 3, we have our divisor. We have 3-digit divisor, right? Minus 2-digit. So our answer is going to be 1. I'm going to use this one over here. Okay. So I'm going to lock my mice. I'm going to lock my divisor. No, my lock my dividend. 7, 7, 4. So that's what I got. That's what it looks like, right? So the question is what? Excuse me. I have to compare. I always have to compare because I need to know what my questions are. So when I look at my questions, it's 7, it's a S and a E. So dividend, I gotta put my labels back. Dividend in the divisor. 4 is my divisor. 7 is my dividend. When we look at it, we're only looking at the first column. We don't look at anything else. So we need to start putting our blinders on. Does that make sense? So we put our blinders on. We only needed to see the 4 and we only need to see the 7. We're going to compare apples to apples. Because we did this, we know that our E is bigger. Our dividend is bigger. Because our dividend is bigger, remember we skip one. And notice when I say 4 times what is equal to 7, this is enough, right? We know you can think of these questions as like turning them into answers. It's more like finding the right. Exactly. Exactly. And so when we look at it, I can show you an example when the quotient is too large. I have to remember that question. When the quotient is too large, there's a couple of procedures, but yes. So here, is there enough? Yeah, we can do it. We can find something that will go into it, right? So 4 times 1 is equal to 4. So all I got to do is add the 1, right? Remember, I have to skip 1. So I add the 1 and I take away 4 here. When I take away the 4, what do I do? Minus the 4 is equal to what? Minus the 5 plus the 1. So we know how to do that. Minus the 5 plus the 1. So my answer, right, is 1. Whatever we do to the first divisor, we got to do it to the second one. So what does that mean? We said 4 times 1 is equal to 4. Then we do 3 times 1 is equal to 3. 3 is a single digit, so I go back one column and I have to take away the 3. I cannot take away the 3. What do I do? Minus the 3 is equal to minus the 5 plus the 2. Minus the 5 plus the 2. Did that make sense? Whatever you do to the first divisor, you got to do it to the second one. I don't know if you call this partial quotient. Are we okay with that? Does that make sense? I know sometimes that gets a little bit tripped up. Whatever you do to the first divisor, you got to do the same thing to the second divisor. Yep. Okay, good. So what's next? Well, we do a comparison again. When we compare, what are we doing? We're comparing 1 and 4. We're not looking at this anymore, right? Our dividend has now changed. So my question is 4 or 1? 4 or 1? 4 is bigger. So now what are we doing? 4 times what? 4 times what is equal to 1? That doesn't work, right? So we got to go to the next number, which is 4. 4 times what is equal to 14 or less? What's the closest number that can go to 14? Not 1. What is the 3? Thank you, Lady E. 3. Yes. 4 times 3 is equal to, thank you, Arnell, is equal to 12. So I'm going to add 3 here. Because I added 3 here, I'm going to take away 12. Take away 1, take away 2. Now, whatever I did to the first divisor, I got to do it again to the second divisor. So I have 3 times 3 is equal to 9. 9 is a single digit, so I go back one column and I add the 9. Did I do that wrong? I did do that wrong. Wait, I did that wrong. I meant 24. I did it wrong. Sorry. 7, 7, 4. 4 times 1 is 4. 4 is a single digit. So I take away 4. Take away 4 is minus the 5 plus the 1. Minus the 5 plus the 1. 3. Take away 3. Take away 1. Take away 2. Right? Take away 3. So now what do I do? Take away. So, oh yeah, I was wrong. I'm wrong. So it's not 1. I did that wrong. How do I know? Okay, wait. Let me go back. So it's 4, 3 divided by 7, 7, 4. All right. So we have 1. 1. Okay. So my quotient's here. My dividend is here. There we go. Okay. 4 times what is equal to, okay, we did 1. 1 times 7 is equal to 4. 4 minus the 4 is minus the 5 plus the 1. So 4 times 1 is equal to 4. And then 4 times 3. 1 times 3 is equal to 3. 3 is a single digit. I go back one column and I take away the 3. When I take away the 3, it's minus the 5 plus the 2. Now I'm left with 3, 4, 4. I don't know how I got 1. I must have moved it too much. So my next question is I still go back. My divisor, my dividend. My divisor is 4 and my dividend is 3. This is the dividend. So my 4 is bigger. 4 times what is equal to 34 or less. 34 or less. Oh, that's what it was. Yep, that was what it is. So 4 times 8 is equal to 32. Take away 3, take away 2. I need to add my 8. Whatever I do to the first one, I got to do it to the second one. So 3 times 8 is equal to 24. So I take away 20 and I take away 4. So my final answer is 18. Yeah, that's what it was. I can do it again. Sorry, let me do it again. That was my bad. Yeah, that was my bad. Yeah, I think it's because I was moving it around too much. So 4 divided by 774. Okay, so we're going back here. That was my bad. So what we're going to do is we're going to compare 3. I have 3 dividends, right? I have 3 dividends and 2 divisors. So 3 dividends and 2 divisors, I know my starting point is going to be 1. That's all I'm trying to do is I'm trying to figure out where my 1 is. I'm trying to figure out where where I put the quotient. So I'm going to do it here. Excuse me. Because I'm going to do it there, my dividend goes onto my abacus. So I have 7, 7, 4. Okay. Now what I'm going to do is maybe I should try to I have to try to keep it stable so I don't move my anyways. Okay. Let me try it again. Okay. The first thing we're going to do is we're going to compare our dividend and our divisor, right? So our dividend and our divisor. Who is bigger, 4 or 7? 7 is bigger, so it's skip 1. We're going to skip this column and we're going to go here. That's the rule. Why? Because my dividend is bigger. If my dividend is bigger, I'm going to go over here no matter what. Okay? So my question is 4 times what is equal to 7 or less? 4 times 1 is equal to 4. So I'm going to put my quotient as 1 and I take away 4. When I take away 4, there's not enough beads to take away the 4. So what do? Minus the 4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1. And then whatever I do to the first, I got to do it to the second divisor, right? You can't just leave that divisor hanging. So 3 times 1 is equal to 3. 3 is a single digit. I have to go back and I take away the 3. I cannot take away the 3. What do? Minus the 3 is equal to minus the 5 plus the 2. So minus the 5 plus the 2. My dividends are still here, so I still have stuff to do. So my next question is what? I need to compare. My divisor is 4. My dividend is 3. My dividend is not 344 because I'm only going to compare one digit at a time. So my dividend is 3. Who is bigger? My divisor is bigger. When my divisor is bigger, my question will be 4 times what is equal to 3. Does that work? No. I need to have one more digit. So this is where the 4 comes in. 4 times what is equal to 34 or less? 4 times 8 is equal to 32. So I add my 8 and my quotient. I take away 30 and I take away 2. Remember, whatever we do to the first divisor, we got to do it to the second one. 3 times 8 is 24. Do I have enough? I sure do. Take away 20, take away 4. So my final answer is 18. 18. So that's how we do 2-digit division. Michael, did that make sense? Hey, Dean. Donku, did that make sense? I'm enlightened. Yeah. Very cool way to do math. Thank you, Mandy. Oh, good. You're still here, Mandy. Very quiet. But it's interesting because they break it up into small ones. Yes, it was nice. I have to go. Okay, yeah. Have a good day. Happy Easter. Thank you so much for joining, Arnell, and I hope to see you in my next live. Yeah. So yeah, I mean that, and it's interesting to see how Abacus does it. Abacus breaks it up into smaller chunks, whereas in school you're told to what times. No, I missed the multiplication. I missed the multiplication equations. We can do it again. We can do it again because I messed it up a little bit. But are you talking about this one, the divisions? We can do it again. This is really close how I work it out problems. This is way more natural. It is, right? Okay, cool. We'll do it again. We'll do it again. I gotta figure out a better way to write this all. You know what I mean? Because I have to move all the time and I'm trying to figure out how to move it. Okay. So let's clear it up. Okay. let's do that. Oh, I'll keep that there. Okay, we'll do that. So 43, divide that by 774. Yeah. Yeah. Danku, I think, yeah, and it's really interesting. I mean, I remember, yeah, I don't know why they did, I don't know why they tell the kids, well, how many times does it go into 70? How many times does 43 go into 77? When they should break it up to be more manageable chunks. So, let's do this one. Let's do this one. So, remember how we found our place value, right? We have 1, 2, 3. So 3 digits is my dividend, and my divisor is 2. So 2 take away is equal to 1. So that means I'm going to be here. I'm going to start this one. Okay. So my quotient will be here somewhere. I'm going to add my dividend, 7, 7, 4. So my quotient is here. Now I'm going to compare. When I compare, what do I do? Maybe I do it here. S and E. How's that? Okay, good. So the first thing we're going to do is we're going to compare 7 and 4. 4 and 7. 7 is, I don't know if you're esoteric comparison, but them taking away as being able to keep track. Those are very big words. Of numbers is a big deal. But them taking away as being able to keep track of numbers is a big deal. I don't even know what that means. Esoteric conspiracies? I didn't even know that was a thing. I'll have to look that up. That's like very big words. I'm a simpleton. Okay, so um, so we're gonna compare. We know 7 is bigger, right? So the question is what? 4 times what is equal to 7 or less? We know this. And then what's going to happen? 7 times 1, I'm sorry. Why are we going to do this? Because we have to skip. This is what that means. Remember that, Dean? So if I have E and E is bigger than 4, if the dividend is bigger than the divisor, I have to skip one column. So I'm going to skip this column and I go over here. I'm going to add my 1 because how do I know? 4 times 1 is equal to 4. 4 is a single digit, so I'm going to just take away 1, right? Take away 4. Take away 4. There's not enough to take away the 4, so what do? Minus the 5 plus the 1. So I'm going to minus the 5 and I plus the 1. Whatever I do to the first dividend, I got to do it to the second dividend. So 3 times 1 is equal to 3. 3 is a single digit, so I have to go back one column and I have to take away the 3. It makes sense to skip another column. Yeah, because it's a single digit. So now 3. I cannot take away the 3. What do? Minus the 3 is minus the 5 plus the 2. So I minus the 5 and I plus the 2. 2. There we go. Yes. So what do? Now my questions is what? I have to compare again. 3 is my dividend. 4 is my divisor. Who is bigger? My divisor is bigger. If my divisor is bigger, then I know I'm going to do 2 columns. How do I know? Because if I do this, 4 cannot go into 3, right? So we need the next number. We need to have the 4. So the question is 4 times what is equal to 34? 4 times 8 is equal to 32. So I add my 8 on my abacus. I take away 30 and I take away 2. Remember, whatever I do to the first dividend, I got to do it to the second dividend. 3 times 8 is equal to 24. I take away 20 and I take away 4. I don't need to add 8 to the abacus because I already added the 8. Thank you guys so much for the hearts. Dean, did that make sense? Thank you, Donku, for the chili. Hey, Ethan! Good evening, Ethan. You're up late. Yeah. Okay, good. And that was the interesting thing about it. Like I was trying to research how does mainstream math do two-digit division? There's not a lot of videos on it. So I guess I'm going to start bombarding the whole world how to do two-digit division on the abacus. It's 18, right? It is 18. You're absolutely right. It is 18. But yeah, I think what I got to do is I got to bombard the world for two-digit division, and I'll just go through one question at a time. I almost got confused because of the placement. Yeah, yeah, the placement is really keen. Is really key. What if your remainder is? What if your answer has a remainder like 9/4? Then you keep it, right? So if we did like, what if we did? I don't know. 6. Excuse me. It would be the same. So if we did like 6, let's say we did 6, right? So it's no, not 36. You know what? 8. We'll do 8. So we'll do 38. So if we did 4 times what is equal to 38, right? 38, so it'd be 9. So we have our 9. So 9, so we take away 30, what was it? 4, 3, 4, 3, 4, 8, 4. Let's try that. Okay, so we did this. Thank you, Ethan. Let me write that down. 25 times that by 8, divided by 8. Okay, so um, take away 30, take away 8. No, take away 30, take away 6. I don't know. Oh, okay, yeah. Oh, if it was 9, so 3 times what is equal to, no, 3 times 9 is equal to 27. There's not enough. So then this is the quotient's too big. So if the quotient's too big, we have to take one from the answer, go back, and then add the divisor. So then we're left with 50. 3 times 8 is equal to 24. So I take away 20, take away 20, take away 4. So then we have to do it again. Who's bigger? They're the same. Skip. No, that doesn't make sense either. I'm missing something. I gotta go. Okay, yeah, I'll see you later, Duncan. Thank you for introducing me. Yeah, not a problem. Yeah, let me try. Let me try Ethan's. So 8 divided by 25. Who's bigger? Well, nothing, right? So it's going to be 8. Where am I going to put it? I'm going to put it here. So 25. So 8 times what is equal to 25 or less? 3. Put 3. Take away 20. Take away 4. 8 times. Sorry, I got to put 3. 8 times what is equal to 10 or less? 8 times 1. So I put 1 and put 2. 8 times 2, 16. Take away 1, take away 4. 8 times 5. So that's your answer. 3.125. What if the problem was to find the answer? Oh, I see. Got it. Okay, well, let's do that. Okay. So, Ethan, this is your answer. 3.125. Okay. So, Michael, thank you. Oh, please. Okay. 4 divided by 9, right? So 4 divided by 9, it's still the same thing. We're going to put our answer here. So if I put our answer here, 9, right? SE4. Who's bigger? This is bigger. So we're going to skip one. So we skip this column and we go here. So the question is 4 times what is equal to 9 or less? 4 times 2 is equal to 8. Oh, I need to put 9. So put 2 here, take away 8. Take away 1, take away 5. Take away 8. Sorry, take away 8. So then after that, I have left with 1. Who's bigger, 4 or 1? 4 is bigger, so I need to do 2. So it's 4 times what is equal to 10 or less? 4 times 2 is equal to 8. 4 times 2 is equal to 8. So I take away 2, take away that. So then 4 times 5. Oh, so that's your answer. 2.25. Did I go too fast? Let's do it again. Let's do it again. So 4 divided by 9. Sorry, I wanted to see what the answers was. Okay, so S and E. Okay, Ethan, let me know if I need to redo it again. I'm so sorry. I'm trying to figure it out. So again, what are we doing? We are one divisor and then one dividend. One dividend, right? This equals to 0. So my place value is 0, not here. This is 1. My place value is here. So my place value is here. I'm going to put my dividend on the abacus. My dividend is here. So what's going to happen is we compare 4 or 9. Who is bigger? My 9 is bigger. So because I do that, I need to skip one column. Skip one. Because I'm skipping one column, I'm going to skip this column and I go here. That's what that means. Why? That's just the procedure. We keep our dividend and divisor here. So what's going to happen is my question is 4 times what is equal to 9 or less? 4 times 2 is equal to 8. So I had 2 is my quotient. And I take away 8. Take away 8. Take away 5, 6, 7, 8. So then I have to compare again. Who is bigger, 4 or 1? Where do I get 1 from? 1 comes from this divisor or this dividend. This dividend is what we track. So who's bigger? My divisor is bigger. So my question is 4 times what is equal to not 1 but 0. Why? Because I need 2 digits. Because my divisor is bigger. Since my divisor is bigger, I need 2 digits. 4 times 2 is equal to 8. So I add 2 here, and I need to take away 8. Cannot take away 8. 8's a single digit. I got to go over here. Minus the 8 is equal to minus the 10 plus the 2. Minus the 10 plus the 2. Now I do it again. Who is bigger? 4 or 2? 4 is bigger. So my question is 4 times what is equal to 2? No, it's got to be 20. It's got to be 2 digits. So 4 times 5 is equal to 20. So if I put my 5 and I take away 2. And my final answer is 2.25. When the divisor, it needs to be 2 digits. Yes, exactly. When the divisor is bigger, it is 2 digits. That's exactly what it is. Okay. If the dividend, then it's 1 digit and you skip. If the dividend is bigger, you skip the one column and you go here, and you're only going to subtract one column. Yeah, you're welcome, Michael. Does that make sense, Ethan? So let's do your question again, because I know I blew through that one too. I'm sorry. So 25, right? This was the question. Yeah. So when we do it, Ethan, we have to find our dividend or our place value. Our place value is 1, so we're going to put it here. That's where we're going to go. Well, you know how I got that, right? Because my dividend and my dividend is 2-digit, my divisor is 1-digit, so my starting point is 1. You remember that? Yeah. Okay, good. So now we do a comparison. Do you remember how to compare? What am I comparing? You tell me. Yes. So my divisor is this. My divisor is 8. My dividend is 2. Who's bigger? Maybe I should do this. Yeah, there we go. That's better. Which one's bigger? My divisor or my dividend? I need more practice to understand division. Yeah. Hello, Angie. Thank you so much for the heart me. Divisor. Divisor is bigger. Yes. So when my divisor is bigger, I need two. Oh, I need to put it in 25. Um, right? So I need to utilize 2 digits. Why? Because when I set up my question, it's 8 times what is equal to 2. That doesn't work. That's why you need the second digit. So you need to add the 5. Does that make sense? So I'm trying to go through logic. Like, why do we set it up? So 8 times 3? Is it 3? Is equal to 24? Is that right? Yeah. So I add my 3 over here. I take away 20 and I take away 4. Minus the 4 is what? Minus the 4 is equal to what? Thank you, Dean. Minus the 5 plus the 1. Yep. Minus the 5 plus the 1. Minus the 5 plus the 1. Who's bigger? 8 or 1? Yeah. It gets a little confusing, but it's all about like just getting used to it. The 8. The 8 is bigger. Yes. So if my 8 is bigger, my question is 8 times what is equal to 1? Is that correct? No, it's got to be 0. That's why we do 2 digits. So what times 8 is equal to 10 or less? 8 times 1 is equal to 8 is equal to 8. So 8, how do I take away 8 from 10? Minus the 8, I don't know if I have room. Minus the 8 is equal to minus the 10 plus the 2. Minus the 10 plus the 2. Is that even right? Yeah, that's right. So now what are we going to do? We're going to keep going. I got to find paper. So we're back to here. My dividend is 8. My dividend, you start off with the dividend on the Abacus, but the end of the answer is left. Yes, yes, that's why I have this. That's why I have this to label, and it moves as I finish the dividends. So my dividend is two, yeah, two. My dividend, my divisor is bigger. So what are we going to do? 8 times what is equal to 2? No, 8 times what is equal to 20? 8 times 2 is equal to 16. I add my 2, I take away 16. Take away 1, take away 6. To take away 6 is minus the 10 plus the 4. So now my next question is what? 8 or 4? 8 is bigger. So what do I do? 8 times what is equal to 4? No. 8 times what is equal to 40? We need to do two numbers. 4 and a 0. 8 times 5. Quotients on the left. Yes, quotients on the left. Add the 5, take away the 40. And it moves. As your dividend gets smaller, your quotient gets more digits. So that's why we move. So my final answer is 3.2125. Yeah. You use the dividend to track the positioning of your quotient. I haven't used my abacus a while. That's why I'm a bit confused. Oh, did that make sense? I took it slower. Did that make sense, Ethan? I realize when I get new questions, I go through it quickly so I can see what it looks like. So, okay, good, good, good. Let me know if I go too fast, Ethan. You have to let me know and say, please do it again. So then I know I can go slower. You know what I mean? You need to let me know. Don't just let me go through it. Okay? Yeah. So when we are working with the abacus, that's why this is movable, because every time you do a quotient, your dividend gets less. And that's why it's interesting to see division on the abacus. And I think it makes it easier, but you got to just keep track of things. It helps you track it, right? But that's the other thing, right? Like we don't need to say how many times does 3 go, like we don't need to say how many times does 47 go into 77. How many times does 43 go into 77? We don't need to say that. We do is we break it up into smaller chunks. And the interesting thing is the abacus does it very elegantly. It's a very elegant method. And whoever thought of it was just, it blows my mind that we have this information and yet we don't use it. So that's what I'm trying to do. I'm trying to show the world, welcome to the real world. On the abacus is much easier than on paper. Yes. You know what? It's also the method too. It's also the method. So in mainstream math, I know when they do 43 and then they do 77 or 74, yeah. What they do is they take it as a whole. They do 43 times that by 2. What does that look like? And then you like work it out. So it'd be 86. Well, that's too much. So then they know that that will be 1. So then they take away 43, right, is equal to 34. But then they have to do this. How many times does 43 go into 344? I don't know. Then they would have to do it. They'd have to go, well, what happens if we did 5? 5 is like 21 5, right? And that's not going to work. So you got to do it again. The teachers say that's the oh yeah, yeah, I don't see why that logically doesn't make sense to me. And the teachers say that's the half of this. Yeah. I don't know. It's too bad that they don't show the abacus way to do division. But I do like division through the abacus way because we break it up into smaller chunks, this and this. So, but yeah, that's the last bit. I'm gonna go have breakfast. Can you do more division now if you have time? You want to do more multiplication? Okay. You know what? Give me a multiplication question. Give me a multiplication question, Dean. I'm sure a kid who does division on paper on Abacus than paper. Yeah, yeah. I mean, but it's a lot about questions and stuff. No, 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 Dean. We'll do one more and then we'll head out. It'll be easy. It'll be easy. How big do you want your multiplication question? That one? Okay, yeah. Let's do that. Oh, okay. So why do I do it this way? I do it this way. You'll notice that there's more steps. What does that mean? Well, you'll see. We'll do it this way. 485. I like it this way because it's less steps. 485 times up by 47. But we're going to do it this way. I'll show you the difference. So we have 5. 1, 2, 3, 4, 5. We know that, right? 1, 2, 3, 4, 5. No, we can't do that. Can we do it? Yeah, you know what? No, we can't do it. Because 16 carry 1. Okay, no, we'll try it. We'll try it. 1, 2, 3, 4, 5. How do we know? 1, 2, 3, 4, 5. We know that. So what are we going to do? We're going to do 4 times 1. I was trying to figure out if I need to use a bigger abacus. That's why. So then we're going to add the 1 and we add the 6. How do I know? Because, let me see if I can do it that way. 4 times 4 is equal to 16. So then we're doing here. 4 times 7 is equal to 28. Is it 28? Yeah. Add 2, add 8. Okay. Now what? We're done with this. We got to reassess. I got to change my... What if I did... Okay, we'll do that. We got to reassess. We got to figure out where we're going to go. 1, 2, 3, 4. So we're going to go 1, 2, 3, 4. So now we're here. 8 times 4. 8 times 4 is 32. I add my 3. I add my 2. Add 3. Cannot add 3. Plus the 3 is equal to plus the 10 minus 7. Plus the 10. 1, 0. Plus the 10. 1 plus the 0. And then minus the 7. Take away 5. Take away 6. Take away 7. And I need to plus the 2. How do I plus the 2? Plus 2 is equal to plus the 10 minus 8. Plus the 10 plus 1 and 0. Plus 1 plus 0. We're done. No, we need to minus the 8. Minus the 8. We're here. 8 times 7 is 56. Yes, thank you, Dean. Yes, that's what it is. 8 times, yes. So now add 56. Add the 5, add the 6. We're done. We're done with this. And then we got to reassess. I got to change colors. Right? 1, 2, 3. 1, 2, 3. 4, 5 times 4 is equal to 20. Add my 2, add my 0. 5 times 7 is equal to 35. Add 5, add 3, add the 5. So my final answer, what's my final answer? My final answer is 2, 2, 7, 9, 5. 1, 2, 3. There we go. 22. We got the 5 because it's 35. Yeah. Not 8. Is it 8? It's not 8. Did I do that wrong? I have to check. Let me check. 47 times that by 485. 22795. Yep. Cool. Yeah, not a problem. No, I still like to check to make sure that I got it correct because there's so many steps. Yep. Cool. Yeah, I need to figure out a better way to organize. But I like the different colors, right? Where they match. So we did this and then we did this. Hi.
Hi, do you have a spare face cam?
No.
Wait.
Wait. I have to check. Let me finish this. I'll do one more. Better safe than sorry. Can you do one more? Yeah, Ethan. Let me know what. Give me a question, and we'll do one more. The blank marker would be way hard to track the equations. The blank marker? Oh, let's see. We do 6.34 times that by 9.54. So what are we going to do? Same thing. 1 and 1 is 2. 1, 2. We'll do here. 1, 2. Right? 1, 2. So we're going to start here. Does that make sense? So we're going to have like our stuff. So what are we going to do? We're going to do 9 times 6. 9 times 6 is 54. Add my 5, add my 4. 9 times 3 is 27. I add 2, I add 7. I add 2. Plus 2 is equal to plus 5 minus 3. I add 2 and I add 7. 9 times 4 is equal to 36. 36. Add 3, add 6, add 3. Plus 3 is equal to plus the 10 minus 7. Plus the 10, take away 7. And then plus 6. So we're done with the 9. Are we all right? So now we know we got to do here. 5 times 6. Maybe if I did this. 5 times 6. 5 times 6 is 30. Add 3, add 0. Plus 3 is what? Plus 3 is equal to plus the 10 minus 7. Plus the 10, take away 7, and then 0. 5 times 3 is equal to 15. Take away, add the 1, add the 5. Plus 5 is what? Plus 5 is equal to plus the 10 minus 5. Plus the 10, take away 5. 5 times 4 is 20. Add 2, add 0. So we're done with this, and now I'm over here. Because we did 2, 1, now we're here. 0. Which column do you start with? No, it's done. If we go to the next one over, it would be 1. Because we finished the 9, then it would be 1. So we go here. So my final answer, so then now I'm here. Because why? Because I'm done with the 9 and I'm done with the 5. Now I'm over here. 4 times 6 is equal to 24. Add 2, add 4. Plus 4 is what? Plus the 5 minus the 1. Then what do I do? 4 times 3 is equal to 12. Plus 1 plus 2. 4 times 4 is equal to 16. Plus 1 plus 6. So my final answer is what? 6, 0.4836. Does that make sense? So when we're done with this, it is no longer 2, it is now 1. So we start here. You counted the decimals after the ones are done. Yes, I counted the decimals after the ones. So anything after the ones is my decimal. Yes. Okay, getting it. You just have to know which column we're in. Yes, yes. And and that's why sometimes you'll see that I break it up and I do this, right? Why? Because sometimes it's difficult for people to see what column we're working on. And so what I do is I have this little contraption thingy that goes like this, right? And we only work with 2 columns at a time. If you really think about it, we only work with 2 columns at a time. We work with the main column, or we take away or add. And that's it. Okay. Yeah. Yeah. We only work with 2 columns at a time. And it's crazy. It's crazy to know this, to understand it. But yeah, we only work with 2 columns at a time. Okay. Okay, so that was it. I'm gonna go for breakfast. And then I guess I won't have my webcam for a while. So, anybody else have any questions? Let me know and we will catch you on my next live. Thank you guys for joining and talking about more Abacus. But yeah, thank you, Dean, for the questions. I do appreciate that. And you too, Ethan. Yeah, 2 p.m., but might as well get breakfast too. Yeah, for me it's 11, so I guess I'll go for lunch. But yeah, it's interesting on how simple Abacus makes it. Yeah, have a good day. Yeah, you too. Have a good day. Thank you again for joining, and I will see you guys all in my next live. Toodaloo, kangaroos!